Hi everyone, welcome back to another video from my channel. In our previous videos, we learned about the measures of location, for example, the mean, median, and the mode, as well as the quartile system, including the lower quartile, the median, and the upper quartile. Similarly, we also found out about variance of a dataset and how we can calculate its corresponding value of standard deviation. Today, we will be learning about representation of data. There are many ways to visually represent features of a dataset to make them easier to understand. Examples of the most common methods of representing data are pie charts, bar graphs, histograms, box plots, and tables. If you remember from our previous videos, we have already covered the fifth one, which is the table. In today's video, we will be discussing the first three, and on a later video, we will be discussing about the box plots. To begin, let us talk about the pie chart. A pie chart is essentially a circle where there will be different size sectors depending on the number of frequencies associated with that specific subject or object. For example, here we have to draw a pie chart for the following data taken from a survey in a school asking children which colors they love most. Here we have a table consisting of color and frequency. If you remember, color is a qualitative data and frequency is a quantitative data. So to draw the pie chart, let us first calculate the total number of students or children that were present during the survey. So summation of F, which is the summation or sum of all of the children here. So by adding them, we can get 21 plus 7 plus 30 plus 11 plus 2 plus 19 plus 16 to get a value of 106, meaning that there were 106 children that took part in this survey. And because we know that a pie chart is essentially a circle, which means if you look closely at a circle, the central angle is going to be 360 degrees, and the way we actually draw a pie chart is by evaluating the ratio. For example, for red or R, we can say that the ratio of the frequency with the total amount is going to be 21 divided by 106, and this is going to be the ratio of the frequency of red with the total number of children. And because, as we know, the total angle at the center of a circle is 360 degrees, therefore we have to evaluate the angle by multiplying this ratio with 360 degrees, and this gives us a value of 71.3 degrees. Similarly, if we repeated this for the rest of the datas, we can say that blue or B has a frequency of 7, as you can see, and the total is 106. So converting that to degrees, we get a value of 23.8 degrees. For green, it's going to be 30 divided by 106 multiplied with 360 degrees, which gives us a value of 101.9 degrees. For yellow, there were 11 students and the total number of students were 106. So we divide that and then we multiply it with 360 degrees to get a value of 37.4 degrees. For indigo, this is going to be 2 divided by 106 multiplied with 360 degrees, and this gives us a value of 6.89 degrees. Similarly, for pink, this is going to be 19 divided by 106 multiplied with 360. That gives us 64.5 degrees. And finally, for the last one, violet or V, this is going to be 16 divided by 106 multiplied with 360 degrees to give us a value of 54.3 degrees. And if you add all of these degrees or angles, you should get a value of 360. For the first one, red, we can say that the angle subtended by the sector made by red is going to be 71.3, which should be approximately something like this. So we can say that this should be the sector shown by red, which is 71.3. For the next one, where we have blue, we can say that the angle subtended by it is 23.8, which is smaller than red. So we can say that blue can be represented by a sector with a size similar to this. So this angle should be 23.8 degrees, which should be for blue. Repeating for the other ones, next we have green, and that should have an angle of 101.9, which should be greater than 90 degrees. So therefore, we can say that it's going to be around here. So this should be the sector subtended by green, which is 101.9 degrees. Then we have yellow, having an angle of 37.4. So it should be like this. This should be 37.4. For the next angle, which is for indigo, it should be a measly 6.89, which is extremely small. And so the sector should show us an angle of 6.89 degrees here for indigo. Then for pink, the next one, it should have an angle of 64.5. So something like this. So this should be 64.5 degrees for pink. And finally, for the last one, which is for violet, we can say that the rest of the angle should be 54.3 degrees. And this should be our approximate pie chart. In the exam, however, when you actually try to draw it, it is recommended to use a protractor to measure the angles and then draw the sectors. And this is how you can draw the pie chart for this table. Now let us talk about how we can draw a bar graph. Basically, a bar graph is essentially a graph with two axes. One is the y-axis and the other is the x-axis. So in this case, the y-axis or the frequency should be here as frequency, and the x-axis should be the colors. So we can say that for the first one, this should be red. For the second one, it's a blue. So we can use a blue color here. Similarly, we have green after that. Then we have yellow. Then we have indigo, pink, and finally we have violet. So the way you draw a bar graph is by drawing rectangles which should have the same width but different lengths depending on the frequency, and each of the bars should be separated by a common gap. Let us first label the frequency. Values. We have 0 here. Then let us assume that this is 10. Then this is 20. And finally, this is 30. So for the first one, which is red, it has a frequency of 21, which is around here. So we can construct a rectangle like this. And this should be the bar for red. Similarly, for blue, it has a frequency of 7, which is around here. So we can plot a rectangle from here, and this should be the bar for blue. Similarly, repeating for the other ones. Next we have green, and the green one has a frequency of 30, which is roughly here. So this should be the bar for green. And notice that distance between the bars of red and blue is the same as the distance between blue and green. Then similarly for yellow, we have a frequency of 11. So it should be around here. So this should be the bar for yellow. Keeping the ratio of the distances same. Then for indigo, it should be 2, which is around here. Then we have pink with a frequency of 19, which is below 20. So this should be the bar for pink, which is something like this. And finally, we have 16 here for violet. So it should be around here. Therefore, the bar should look something like this. So we can color code them. For the red one, let us fill that with red. For the blue one, should be blue. And green, then we have yellow. Then indigo. Then pink. And finally, violet. And this is going to be the bar graph for the data. Now let us move on to histograms. Group continuous data can be represented in a histogram. Generally, a histogram gives a good picture of how the data are distributed. It enables you to see a rough location, the general shape, and how spread out the data are. In a histogram, the area of the bar is proportional or related in size to the frequency in each class. This allows you to use a histogram to represent group data with unequal class intervals. In a histogram, to calculate the height of each bar, which is the frequency density, use the formula where area of bar is equals to k into frequency. K is equals to 1 is the easiest value to use when drawing a histogram. If k is equals to 1, then frequency density is equals to frequency divided by class width. Joining the middle of the top of each bar in a histogram forms a frequency polygon. If you remember when we discussed about the bar graph or the bar chart, it usually has a qualitative data here and frequency here or the number here. And the bars were separated with a specific gap here, which looks something like this. Whereas in a histogram, all of them are connected to each other and there are no gaps. Similarly, we are dealing here with a continuous variable that can have any variable in this given range. For example, length can be anything from 0 to 16, like 0.5, 1.5, 2.5, and so on. So this is continuous, and this is the main difference of a histogram and a bar chart. There are some things to know about a histogram. Mainly, the y-axis is actually the frequency density rather than the frequency itself, and the x-axis is going to be a variable. For example, it could be a time or mass or length, something that can have any values, meaning that it should be a continuous variable. And here in histograms, you have to remember that the frequency is actually proportional to the area of the bars represented in a histogram. For example, let's say if this is a bar with a specific value of frequency density or FD, and it has a certain class width. If you remember what the class width was, it was the difference between the class boundaries, or this can be noted as CW. So the frequency is going to be proportional to the area of the bar or area of the rectangle here. And so frequency is proportional to the frequency density multiplied with the class width. And so using the proportionality rules, if y is proportional to x, we can represent this in an equation by saying y is equals to kx, where k is a constant. So in this case, we can also say that frequency is going to be some constant, which is k, multiplied with frequency density and multiplied with the class width. And this is a very important formula to remember when you're dealing with histograms, may it be for drawing it or solving questions regarding them. So now let's do a question regarding histograms. The partially, not entirely completed histogram shows the time in minutes that passengers were delayed at an airport. For number A1, we have to copy and complete the table. So here we are given the frequency and the class boundaries as well, and some of the bars are given here. So using the first bar, we can say that the area of the bar represented by time 0 to 20 minutes is going to be the frequency density multiplied with the class width. So here in this case, you can see that this is the frequency density, and there are 5 divisions representing 1 unit here. So because 5 boxes represent 1 unit or 1 frequency density, therefore 1 box is going to represent 1/5 of the unit. So therefore frequency density is going to be 1/5 here, and the class width, which is the length of this, is going to be 20, as you can see, which gives us 4. If you remember the formula, frequency density is proportional to class width into frequency density. So we can use this formula, F equals to K into area of bar. The area of bar was 4 here, as we have found, and the frequency is given as 4. Therefore, we can say that K in this case is going to be 4 divided by 4, which is 1. So this makes the histogram more easier to draw. For the second one, we can see that it has a class boundary of 20 to 30. So this length is going to be 10, and this is going to be 1, as you can see from the graph, meaning that frequency is going to be K multiplied with the area of bar. So because K is 1, so we can simply write 1 multiplied with 10 into 1, which is the area of this bar, and this gives us a value of 10 here as the frequency. So this should be the frequency of the second column. Now for the rest, here we have 10 again, and here you can actually see that this is not at a solid point, meaning that it's actually at the half of this point. So here we have 1, 2, 3 divisions, and this is going to be 3.5, meaning that there are 3.5 divisions. So as we have discussed here, if 5 boxes represent 1 unit, therefore 1 box represents 1/5 of that unit, or 1/5. Therefore 3.5 boxes should represent 3.5 multiplied by this fraction, so 3.5 into 1/5, and this gives us a value of 0.7 for the frequency density. So using the formula, F is equals to K multiplied with area of bar, we can say that K is 1, so 1 multiplied with area of bar being frequency density, which is 0.7, multiplied with 10, which is going to be 7 here. So the frequency is going to be 7. Similarly, for 50 to 70 minutes, the class width is going to be 20 here, because 70 minus 50 is 20. And if you also zoom in, you can see that it does not end in an integer number of boxes. Rather, this is the first box, and it ends at 1.5 boxes. So we can also convert this again. 1.5 boxes should mean a value of 1/5 multiplied with 1.5, and this gives us a value of 0.3. Now we use the formula again. F is equals to K multiplied with the area of bar. So F is going to be equals to K, which is 1, multiplied with the frequency density, which is 0.3, and then multiplied with the class width, which is 20. So multiplying this gives us 6 here, meaning that the frequency is going to be 6. So for number A2, we have to copy and complete the histogram. As you can see, we do not have to copy it because it's already given here. Now what we have to do is we have to find out the frequency densities for these two classes because we are not given that. One is from 30 to 35 at here, and the other is from 35 to 40. So here for the first one, frequency is 15. So we can use the formula F is equals to K multiplied with frequency density into class width. For the first case, 30 to 35 class, frequency is 15. The value of K is 1. We do not know the value of frequency density, so we put it as X. So 1 multiplied with X here. And then the class width is basically 5. 35 minus 30 is 5. So we can find the value of X here being equals to 15 by 5, which is 3. So the frequency density for the first one is going to be up to 3. So you can draw a straight line starting from here. And similarly, this will be at here because it ends at 3.5, something like this. And then we complete the rectangle like this. Then we can shade this with purple. In the exam, we do not have to shade this. This is purely for aesthetic reasons. Similarly, for the next one, we can still use the same formula. F is equals to K into frequency density in the class width. So for the second one, 35 to 40 class, the frequency is 25. So we have 25 equals to 1 into X into 5 again because the class width is 5, which is found by subtracting these two class boundaries. So therefore, we can get a value for X being equals to 25 by 5, or simply 5. Now we complete this histogram. So we're gonna have to draw a straight line starting from these 2 points. So something like this. And then finish it off by drawing the width here. Then we can also shade this, giving it a slightly different shade. And this is our answer. For number B, we have to estimate how many passengers were delayed between 25 and 38 minutes. So from 25, it's going to be from here, and then up to 38, which is around here. So we have to calculate the total number of people around this range. So you use the same formula. F is equals to K multiplied with frequency density into class width. Because K is 1, we do not have to write that again. So for the first one, the class width is going to be 5 because 30 minus 25 is 5, and the frequency density is 1 here. So we have 5 multiplied with 1. Then this frequency, which we have already found being 15 here, which is the frequency of the class of 30 to 35. So plus 15. The next one, we have a class boundary of 38 and 35 here, as you can see here, which is 35. And the class width should be the difference between the two, which gives us 3. And we have calculated that the frequency density was 5. So it should be simply 3 multiplied with 5. And calculating all of this, we get 35 passengers. And this is our answer. Thank you all for watching. Please make sure to leave a like, comment, share, and subscribe if you enjoyed my content. See you guys in the next video. Goodbye.